Question number 7. Two right triangles must be congruent if an acute angle in each triangle is congruent, the legs of the hypotenuses are equal, the corresponding legs are congruent, or the areas are equal. Now, this is a type of question that students will see and they don't see a picture and they just kind of use their intuition. Maybe you want to do that, but I really like to draw a picture out for each one of these different scenarios and maybe even a couple pictures to prove to myself, whether or not it must be congruent. So let's take a look at each one. We'll draw a picture for each and every single one of these. All right, so answer 1. An acute angle, so I want to see, this is saying it must be congruent if, I'm going to try to draw pictures that make them not congruent. Because if I can draw a picture that shows that they're not congruent, well then I know that that's not the right answer. So, an acute angle in each triangle is congruent. So this one, you might be tempted to draw, all right, it's a right triangle, so I need to have a right angle. And then you're going to say, well, if this angle is equal to that angle over there, I've got 90 and 90. This angle over here with this angle over here, well then 180, these angles must all be equal. And you might be thinking that they're congruent. But don't forget, angle, angle, angle only gives similarity, and that's because I can draw a triangle that's much bigger, but that still has this right angle, this same equal angle over here, and obviously my bigger triangle, even though all the angles are equal, is not congruent to my smaller one. So 1 cannot be an answer. Number 2, let's try and come up with a counterexample for number 2. Two triangles must be congruent, two right triangles must be congruent if the lengths of the hypotenuses are equal. Well, I might actually be able to prove this one wrong instead of by drawing a picture, but by using Pythagorean theorem. I know that a squared plus b squared must equal c squared for any right triangle, right? Where my legs are a and b, c is my hypotenuse. Well, let's choose, what happened to my camera? What's going on here? Come on. Let's choose some c for two equations and see if I can come up with a's and b's that don't equal with each other. So for this first one, I'm going to choose, what's a really nice c? How about c squared is 100 is equal to a squared plus b squared. Okay. And then I'll keep that 100 here in the second equation. But this time, so I've got a squared plus b squared equals 100, a squared plus b squared equals 100. I'm going to choose some a for each of these and see how it works out. What's a nice one? 4 and 6 works well for that, right? Yeah. So for this, I'm going to say, all right, a is going to be 4. So this will become, so c was 10. A I'm saying is going to be 4. And b can be, no, it's not 4. It should be 6 and 8. 6 and 8. And that way I'll get 36 here and 64 here equals 100. So here I have the hypotenuse is 100. My leg is 6, my other leg is 8. Sorry, my hypotenuse is 10, my two legs are 6 and 8, and that fulfills Pythagoras. Now, what if I say, you know what? I want leg A to be 5. So I'll do 5 squared plus b squared equals 100. And the reason I'm choosing my leg to be some different number is because I want these two triangles that I'm making to not be congruent. I want this part to not have all the same legs as this part, even though the hypotenuse is the same. So now I'm going to get 25 plus b squared equals 100. Take away 25, take away 25. B squared is equal to 75. Ooh, square root of 75. That's not a really nice one. It's above 8, below 9. Square root of 75 is 8.66. So that means that b, square root to both sides, gets me 8.66. Well, I just showed a case of the hypotenuse being equal, but my legs being different. Here in this triangle now, I've got another hypotenuse of 10, but now one leg of 8.66 and another leg of 5. So here I have one triangle with a hypotenuse of 10, legs of 6 and 8, another with a hypotenuse of 10, legs 8.66 and 5. So these two triangles are not necessarily congruent, so it must not always be congruent. That means 2 is not an answer. Let's take a look at number 3. Okay, so for number 3, let's say I've got a triangle here, and it's a right triangle, and the legs are equal. Uh-oh, this looks like it's going to be my answer. And you can see just by drawing it. If the legs are equal, so that means I've got the corresponding legs are equal. That means I have, let's say this is 3, that's 3. Or more in general, this is equal to that. And then maybe I'll say, all right, this is 4, this is 4. These numbers, I'm just, for these kinds of questions where you are trying to come up with counterexamples, these numbers aren't really, you can get some practice coming up with ones that will work better to show counterexamples. But as long as you're consistent and say, all right, the legs must be the same, it doesn't matter if I chose 3 or 27 or 54 for this leg, or 4 or 11 or 3.47 for these legs. As long as I'm saying, all right, the corresponding legs are congruent, it will help me prove my point. If I've got 3 here, 4 here, and a right triangle and a right angle, 3, 4, 4 here, and a right angle, well, I see that this is side, angle, side. That means that these two triangles are going to be congruent. And no matter what numbers I choose, it kind of helps me visualize it more. But no matter what numbers I choose, I'm going to have a side, angle, and side matching with the side, angle, and side. I'm pretty sure 3 is going to be our answer. But let's just disprove 4, just to, finish up this question. The areas are equal. 2 right triangles must be congruent if the areas are equal. Well, area for a triangle, you can remember that by saying, all right, well, a square is base times height. A triangle is half a square, so it's going to be 1/2 base times height. Or you can just use the reference sheet for that as well if you'd like. So I have 2 right triangles. They need to have the same area, and they must be right. And are they always going to be congruent? I'm thinking not. So let's see. Let's say my area is, what's a nice one after a half? Maybe 40? Let's do 40. My area is 40. So I can say, all right, area of triangle 1 should be equal to half of base times height. What about this side? So it's got to be, what about 8 and 10? Well, my area should be 40, so I can say, all right, 80 and a half. This becomes 40. Area 1 was 40, and I used the legs of 8 and 10. It's the legs because I'm making a right triangle. So area 1 was 40. I'll come up with area 2. That's also 40, but I'll use different legs. Why don't we use, how about, what's another thing that will multiply up to 80? 80 divided, 80 divided by 4. That's nice. All right, so what if my legs were, area 2 should be equal to 1/2 of 4 times 20. So now I've got one triangle over here who's got a leg of 8 and a leg of 10, still has an area of 40. Here I've got a triangle with a leg of 4, a leg of 20, and 4 times 20 is 80 times 1/2 is still going to be, area 2 will be 40. Well, here's 2 triangles that each have an area of 40. They're both right triangles, but they're not congruent. So therefore I can say 4 is not my answer, and I can come up to the correct solution of 2 right triangles must be congruent if the corresponding legs are congruent. Now, you do not need to feel like you need to spend this much time and put this much work when doing this Regents question. I just take the time so that if anyone has any questions, I've gone through every bit of the question. So this Regents question, I hope doesn't take you 10 minutes like this video did, but going through each and every part, I hope for anyone that was confused, you now really understand why the answer is 3.